to find the point 2 and 5. On the x-axis, you're going to move 2 units. On the y-axis, you go to 5 units up. This is the point that we're talking about. This is the point, first point, 2 and 5. So I'm going to, for those of you watching this later, I suggest you pause the session now and see if you can locate these points here on the graph. That's the first thing we're going to do. So let's take a look and see if you are having the same points here. So these would be the locations of the points. -4 and 1, you move 4 units to the left, 1 unit up. That would be right there, -4 and 1. -4 and -2, again you go -4 on the x-axis, 2 down. And then next one here we have the -5 and -5 would be here. I'm just going in any order. This is 2 and 0. You go 2 units to the right, 0 up or down, right here. These are the points on the y-axis. So you see, for both of these 2 points, x is 0, y is -2 and -3. So these are the location of the points. The solution to a linear equation in 2 variables is an order pair xy that makes the equation a true statement. For the linear equation, 2x minus 3y is equal to -12. Determine whether the order per 0, 4 is a solution. For those of you watching this later, pause the session, see if you can get the same answer. So all we have to just do is to substitute for each x 0, for each y 4, see if it adds up to -12, and looks like it does. You just substitute the numbers. 0 minus 12 equals to -12, so yes, it is. That's a solution. It's a solution to the linear equation, and also is a point on the line. To graph a linear equation, like in these 2 examples, 2x minus 3y is equal to -6, y is equal to 3x minus 2. I want you to fill out this chart. When x equal to 0, solve for y. If y is equal to -2, solve for x. If x equal to 4, solve for y. These are the specific points that we need to find, locate, and then connect them together to graph. To graph any line, you only need 2 points. You can use any 2 points, but in these 2 examples, they want you to specifically find these points, locate them, and graph them. Please pause the session so if you can get the same answer. So let's take a look at the solution to compare our answers. Here it is. When x equal to 0, you substitute for each x0, you solve for y. You find y is equal to 2. You locate the point, 0 and 2. This point here, known as y-intercept, if you let y be equal to -2, solve for x, you would find another point here, -6 and -2. If you let x be equal to 4 and solve for y, here you get a fraction. You could get a fraction. So for those would be approximate point right there. So these are the 3 points on the line. Next example, y is equal to 3x minus 2. We have to evaluate y when x equal to 0. In other words, we want to find a y-intercept. If x equal to 0, y is equal to -2. So that's the y. This is the point where your graph going to pass through the y-axis. That's why they call it y-intercept. And there are a couple other points we have to find. When x equal to 2 or 4, we substitute those values. We find the corresponding number for y. We look at the points, and this would be a graph of these lines. Here's another example. Y is equal to 1/4 x plus 1. We want to find these 3 points. We want to let x equal to 0, 4, 8, and find the corresponding values for y. Locate the points and graph them. Here there's a little hint here. It says because you are multiplying by 1/4, it is easier if you choose values of x that are multiple of 4. That's why they're asking you to find the values of multiple of 4, so you don't get a fraction. If x equal to 0, solve for y. If x equal to 4, solve for y, and so on. So I would pause the session now. For if you're watching this later, I suggest you do the same so you can compare your answer with us. Let's take a look at the solution and compare answers. There it is. If x equal to 0, you see y is equal to 1. This is the point. If x equal to 4, 4 over 4 is equal to 1, so y is equal to 2. If x is equal to 8, 8 over 4 plus 1 is equal to 3. So you see, you get the nice line, linear equation here by connecting those 3 points together. To find the x-intercept, you let y be equal to 0, solve for x. To find the y-intercept, you let x equal to 0, solve for y. So I want you to find the x and y-intercept for this and graph them. 4x minus y is equal to 8. That's all I need are 2 points, the intercepts, and connect them together to form the line. For those of you watching this later at home, please pause the session and compare your answer with us. This is the standard form. A standard form is ax plus by is equal to c. So in this case here, we have 4x minus y is equal to 8. And to find the x and y intercept, let x equal to 0. What is y? Negative 8, right? Okay, if y is equal to 0, what is x? Would be 8 over 4 or 2. You see, I'm finding the x and y intercept, but if this equation was not in the standard form, what if it was, if I move this y over here and 8 over here, then it won't be a standard form anymore, right? So let me rewrite this as 4x minus 8 is equal to y, right? Or if I write it as y is equal to 4x minus 8. Now there's a name for this, also a slope-intercept form. So this is a really useful form, actually, better than standard form, because just by looking at this, I can find the slope. We're going to talk about slope a little bit later, but as you can see, this is not a standard form. I can find the x and y intercept the same way. If I let x equal to 0 over here, still y is equal to negative 8, right? So it doesn't have to be in standard form to find the x and y intercept. Could be in any form and locate those points. Okay? So over here, as you can see, we find the x and y intercept, you locate those points, and that's my graph.